problem number 14 says if g is differentiable, which just means it is smooth. Okay, so I have a smooth function, no sharp turns on the closed interval. Which of the following must be true? Okay, so it says for every x in A and B, g of x is between g of A and g of B. Well, let's assume this is A and this is B. I don't really know where g of A is. Let's just assume g of A is there and g of B is there. This does not have to be true because g of x, who knows, it might go up and over or way under. So in other words, it doesn't have to be in between this height and this height. It could take on any height it wants, so it's not A. B, it says for every k between g of A and g of B, there's a value c, such as g of c is equal to k. Okay, what that picture is simply saying is if here's A, here's B, okay, here's g of A, here's g of B, okay, as long as there's a point in between these two heights. Okay, so you pick any point in between these two heights. What it's saying is there has to be some point C that's in between A and B such that g of c is equal to k. So k being anywhere in between here. And that does have to be true. What this is actually, this is the intermediate value theorem, which is saying to get from this height to this height, you have to cross every height in between. So B is your correct answer. Okay, let's look at the other ones though. There's at least one x such that g prime is 0, so it's saying that there's a point where it levels off. But I could draw a graph that has no point that levels off like that. There's never a derivative equal to 0. The limit does not exist at infinity. We don't know anything about that. And g double prime is equal to 0, saying there has to be a possible point of inflection. And again, if you look at my graph, there's not a possible point of inflection, and especially at 0, since I don't know where A and B are, so that's not a choice. Question number 15, what is this limit? So again, we're being tested L'Hopital. If you plug into the top, e to the 0 is 1, minus 1. If you plug into the bottom, I got tan of 0, which is 0. So I get 0 over 0, which is indeterminate. L'Hopital applies. I'm going to go to the limit. As x approaches 0, the derivative of e to the 2x is 2e to the 2x. All over, the derivative of tan x is secant squared x. Okay. Now if I plug into the top, I'm going to get 2 times e to the 0, which is 1. And then secant squared at 0 is also 1. Secant being 1 over cosine, so the answer is D. Question number 16 is related rates. The radius of the sphere is increasing at a rate of 0.3 inches per second. Okay, keep this in mind. So the radius is increasing, so dr, the radius, it's increasing. dr dt is 0.3 inches per second. Okay, so inches for radius times seconds. At the instance when the area S becomes 100 pi, I think they mean surface area, what is the rate of increase in cubic inches per second in the volume? So here's the formula for volume. So if we find dV dt, we bring down to 3, so it becomes 4 pi r squared dr dt. Okay, but what do we know? We know that the surface area, S, is 100 pi. S is 100 pi. Look at this. This is S, so that's actually going to be 100 pi. We know dr dt from before is 0.3 inches per second, 0.3 inches per second. So it looks like the correct answer will be E. On the test, the problem is going to involve a ladder. So the equation you're going to need to know is Pythagorean.